After all this time. Found yourself a way out of this small town. Got a place at school you didn't hang around. Every day you're far away, these streets don't feel the same. Everywhere is painted with your name. I remember that I was drunk out my mind when we kissed for the first time. In the back of your car we passed out, counting stars. Promised all these years we'd pack up things and disappear. I never thought I would see you here. After all this time. I remember that I was drunk out my mind when we kissed for the first time. In the back of your car we passed out, counting stars. Promised all these years we'd pack up things and disappear. I never thought I would see you here. Try to replace you with somebody out there.
If I didn't chase you, would you even care?
And if I lost my mind, would you come around? I will keep you safe and sound. After all this time.
Words spill out of your mouth. You wish you were someone else. I miss you, but I know you miss your old self too. Silver once golden. There's only so much holding on. You can't take when your mind's at stake. Oh wait, do what you gotta do, what you gotta do to be you again. Do what you gotta do, what you gotta do to put your heart to rest. I'll keep waiting as
Where's this you know there?
it takes. Do what you gotta do, what you gotta do to be you.
Where's your red wood? You ready? Oh lord. Oh, you ready? Oh, let pick up what I put in down today, okay? And I have to pick it up. So I say Man U better than Madrid. Man U having no Champions League, you know? Man U not even in Champions League next season. Sure, I'll go watch this football on a Thursday. Did they even qualify for Europa? Hey, World Cup qualifiers going on? Oh no, in the UEFA Nations League. Trinidad playing tonight, fellas. Trinidad playing tonight. I reckon they're tired. They're tired. I got working, man. What topic? We will continue with the a little bit of the calculus. Then we will do a little bit of integration. Then we will do kinematics in about, I'll run through kinematics in 20 minutes. Then there is done. What was that? So I say we're doing differentiation, integration, kinematics, AP, GP. What's all about? APs, GPs. Do you stop margarine my caramel, please? This mine. Whoa, it's mine. Whoa. Relax. Rectify yourself. Yeah. What does the people want? Well, again, a little ASMR one time. Stats and probs. Yeah. Probs and stats. Now, I ain't too comfortable going through percentiles on him. I can review some of my notes to go through some percentiles, right? I know a couple of students requested percentiles. I'll go try my best. Like 5 so far, right? Let's put time. Time constraints. Differentiation, applications, $15 minutes of theory, integration will be at 20 minutes, kinematics will also be at 20 minutes, APs and GPs are 20 minutes, probably AP and stats will be like half an hour. Alright, what is ASMR? Look it up. Look it up. Where kinematics in the back there. Oh yes sir. Kinematics. Hey. Alright, let me wait for a couple more people to jump out. After the stream? Nah, not yet. But earlier I still have to finish much more things in integration. Yeah, colorful applications of calculus, again that. If that is what the people want, that is what the people could get, right? What kind of ASMR? Tea-sipping ASMR. Don't fight them. APs and GPs there, boy. Look, APs and GPs is number 4. I know it's a little far away and thing, but APs and GPs, they don't fight up yourself. General tips for the exam tomorrow. Don't be anxious. Do the questions that you're comfortable doing. The questions are going to come in a particular format. Question 1 is going to be a functions and stuff. Let me do say and stuff, right? Let me make reference to the specimen paper. Right, in 2019 there was a specimen paper which 2018, sorry, there was a specimen paper which would have gave you all an idea on the structure of the exam. So there would have been specimen paper 2018. I think so, you know. I think it's 2018. Right, so nice specimen paper 2018. Yes, it was in 2018. It was the exams from 21. Do our shorts? Yeah. I'll do that. But to manage them shorts, I want to. Alright. I will figure out what to do. The ping not too hot. Yeah, well, I the closest marker I had, so hard luck. Alright, so in specimen paper 2018, question 1 was functions and quadratics, remainder and factor theorem, and completing the square. Alright, now I have to squeeze in our logs in there as well. So element complain about the pink marker. Do complain. 6. What it was? Logs. Do complain. Alright. Yeah, question 2 will be a logs and inequalities. I'll show you all the shortcuts for everything. Alright? Without going into context. Diving deep into context, right? APs and GPs as well as part of too. Please, for the love of God, for the love of me, do not use all your POA and I think it's POA or POB formulas in maths, because I know there's a formula and a counts formula for compound interest. Don't use that, please. I'll open it. Right. I'll open that from here now. I'm gonna lower this down. Bam. Alright, I'll open it. Now I wouldn't go over. Oh shit, wrong account. I wouldn't go over inequalities. I will show you all exactly what to do for inequalities, right? We push in until we could push no more. Or until I could push no more. Alright, now I don't mind button. I go but last man belly full. So that's things that come in from number 2. Number 3 is a bit of trigs and coordinate geometry and vectors. Number 4 Number 4 has both calculuses, integration and differentiation, and kinematics. We will start off about next 10 minutes. I think now we're just going through the specimen paper right now. Number 6 is your probability and statistics. So it's just wait. Correct me if I'm wrong. It's just 6 questions that come in. Yeah, in school we do now this, man. Just 6 questions, right, Talia? The food, man. Food, I'm telling you, food, dog. Real food. Alright, let me start. Now, in the last live, we tackled some calculus, differentiation. We're gonna go to some applications of differentiation. Plain talk, bad manners is what we're going to go with. I'm not going to explain anything to all because the exam is tomorrow. I'm going to tell all what to do. If all you want to know what to do, why we just do what we just do, voice your concerns in the comment section. Let me just put on my socks. Place making little cool. Watching the chat here. So I go until 2 and thing. Alright, Bridget, you big up your whole self. What kind of food has I had? Did you guys watch the trigonometry video? That trigs playlist should clear up every single thing on trigs. Did you all watch it? Yes or no? Alright, Gerard, food. Alright, Jared, Corellis is good enough. Corellis are quietest. Alright, so a question is going to ask you guys, we starting, right? A question I'm going to ask you to calculate the coordinates of the stationary point on a curve. Now, just remember this, right? Watch this. Don't watch it in the morning, Quill. You have to watch that directly after this live was. At a stationary point, dy dx is equal to 0. That is the first thing you need to know. A stationary point could be maximum, minimum, or inflection. I don't think CSEC will test inflection, right? Maximum or minimum. Now they could also ask you at a turning point. So whenever you see the words max, min, stationary, turning, dy dx is equal to 0. Or the first derivative is equal to 0. So let me do an example. Y is equal to 4x squared plus 2x minus 3. I want to know the coordinates of the stationary point here. As soon as I see stationary point, dy dx is 8x plus 2, and I will I just put a statement at a stationary point, dy dx is equal to 0, let 8x plus 2 is equal to 0, and x is equal to minus 2 over 8, which is minus a quarter. Now this is the x coordinate for my stationary point. To get my y coordinate, I had to get y is equal to something. So I plug in x is equal to negative a quarter into y to get y is equal to something. And then we'll do a past paper question, right? Pick a year for all it to do, oh Lord. Pick a year all you want to do a past paper questions from, and I'll select that particular question from that year. When x is minus a quarter, why are we talking about? Y is equal to 4 into minus a quarter squared plus 2 into minus a quarter minus 3. Don't afraid to use a calculator earlier. Don't be afraid. Put your brackets where you have to put your brackets. Minus 1 over 4 squared plus 2 into minus 1 over 4 minus 3 minus 3 and a quarter, or minus 13 over 4. So the coordinates of the stationary point is going to be my x coordinate, then my y coordinate. Then they're going to ask you for the nature. Nature, taking a little turn here, nature comes from the second derivative, which is d2y over dx squared, right? d2y dx squared. Now the 2 on the numerator is a power, right? So it's actually written as d2y over dx squared, and we call it d2y dx squared. That just means I have to differentiate again. So d2y dx squared means I have to differentiate this here. Okay, now for this particular case, it's kind of not applicable. So when we do our question, we will apply this fella to the question. So let me pull out our question here, right? Some says 2018. Let's work with the specimen paper. All right, I'll work with specimen paper 2018. The calculus question didn't have nothing to do with stationary points. Brilliant. 2019. Alright, 2019 was a difficult one. Let me make up a question. Make up question time. We're going to calculate coordinates of stationary points, nature of the stationary points. Real easy thing. So the question will state, determine the coordinates and nature of the stationary points to the curve. And let me draw a curve now. I want to make sure I'm trying to work with two stationary points here, right? So I'm gonna draw on two stationary points. Y is equal to 4x cubed plus 2x squared plus 3x minus 3x. I like that one. Plus 4. Cool. I like that curve. 4x squared plus 2x, 4x cubed plus 2x squared minus 3x plus 4. 4x cubed plus 2x squared minus 3x plus 4. First things first, I see nature, I see stationary points, so I know it's differentiation I'm dealing with. Stationary points, I know dy dx is equal to 0. So if y is equal to 4x cubed plus 2x squared minus 3x plus 4, I write down what dy dx is now. Nobody go back to chair. I get 12x squared plus 4x minus 3. And we state at a stationary point, dy dx is equal to 0. So we let 12x squared plus 4x minus 3 is equal to 0. Use your quadratic formula, right? Use your quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All I go do all the working, all is big people, all is supposed to know how to do that. If all I don't know how to do that, let me know. You could also use a calculator. If you have my version of the calculator, the EL506TS or above, you can solve quadratics and polynomials on it. Mode 2, enter what A is, enter what B is, enter what C is. I get my first value is 0.36. 0.36. And because I'm calculating points of coordinates of stationary points, and x is equal to negative 0.69. Now these are approximations, okay? So I just have the x value, I need the corresponding y value, so I have to get y is equal to something. When x is equal to 0.36, y is equal to 4 into 0.36 cubed plus 2 into 0.36 squared minus 3 into 0.36 plus 4. Punch this in a calculator. 4 into 0.36 cube. 4 into 0.36 cube plus 2 into 0.36 squared minus 3 into 0.36 plus 4. I get 3.37 approximately. 3.37. Barring I make any calculation mistakes, this could be one of the coordinates of the stationary points. When x is equal to negative 0.69, I'll address the comment section just now, right guys? The chat, sorry. 4 into negative 0.69 cubed plus 2 into negative 0.69 squared minus 3 into negative 0.69 plus 4, 5.71. So two stationary points going to have, one of them going to have coordinates 0.36, 3.37, and the next one going to have coordinates 0.69, 5.71. So I could actually check it for myself. Cool. I could check the points for A and the points for B. So you can see one of the stationary points is 0.36, 3.37, and the next one is negative 0.69, 5.7. 5.71. So yeah, again, questions, ask. Easy shit. Yeah, real easy shit. Next, nature. Nature comes, like we said, it comes from d2y over dx squared. I just had to differentiate again. So I differentiate in homeboy again. I get 24x plus 4. Now, this is where I want to be extremely specific. When using d2y dx squared, I will be using the x coordinate for each stationary point. I am substituting the x coordinate into d2y dx squared. So I'll say, this is for nature. When x is 0.36, d2y dx squared is equal to 24 into 0.36 plus 4. Again, jump on the handy dandy calculator. 24 into 0.36 plus 4, 12.64. I'll adjust that just now. When x is equal to negative 0.69, d2y over dx squared is equal to 24 into negative 0.69 plus 4, 24 into negative 0.69 plus 4, negative 12.56. So this is where we're going to address nature. If d2y dx squared turns out to be a positive number, like positive vibes, you understand? Positive vibes mean we irie, we happy. We happy means we smiling. We smiling means we have a minimum point. Negative means negative vibes means you're not really irie, we sad. So we have a maximum point. So your state at 0.36, 3.37, there is a minimum point because this was the x value I used to get this one here, and at negative 0.69, 5.71, there is a maximum point. Keep, rinse and repeat. The hardest thing is to actually calculate dy dx and d2y dx squared. Alright, so I'm gonna check and see what we're on here. 28, second derivative, right? Will you lose marks if you don't show the working and just plug in the values into your calculator? No, you will not. You will not lose no physical marks, but that's not the only criteria you are marked on. Yes, you are marked based on working, but you are marked based on showing working as well. Alright? It wouldn't go for no physical marks, but remember you were all A's in the profile. Cool? So all A's in the profile, you need to show all working. It's not going to take long if you know what you're doing. Come on, let me be real quick. Right, Ismail, let's say unit 1 paper was food. Yeah, it was real food horse, like real food. Food, like price food. Alright, moving along. Any questions on calculus? This is the application of differentiation. Right? This is the application of differentiation. Calculating maximum and minimum points, maximum and minimum values. I really don't see questions coming any different other than in 2018. Very good, Bridget. If they give you marks, if you make a mistake, you get something called error carry forward. Writing statements matter a lot. Yes, it does. I will say writing statements matters a lot if you want to get your distinction. Again, it's not going to take long to write your statements. All right, integration time. Similar to differentiation, integration, well, is the opposite of differentiation. So, just now, Josiah, take a time. I have to show you integration first because kinematics has both integration and differentiation in it. Integration is the reverse of differentiation, and it follows the law. If y is equal to same thing, ax to the n, then the integral of y with respect to x, just like how I have the differential of y with respect to x, I have the integral of y with respect to x is equal to ax to the n plus 1 over n plus 1. So I'll just do two examples. Y is equal to 4x cubed plus 3x to the power 6 minus 11x. The integral of y with respect to x will be the integral of 4x cubed plus 3x to the 6th minus 11x with respect to x. And the law says I have to add 1 to the power and then divide by that new power. This is 4x to the power 4 over 4 plus 3x to the power 7 over 7 minus 11x to the power 2 over 2. You could cancel if you want to, but we always have to add in a constant of integration called plus c. Always, where c is a constant. Right? Where c is a constant. Now, same rules applies for differentiation, just as for integration, just as differentiation. The variable must be on top, and the variable must be raised to some power. Now, there are some special cases. One important case, one very, very important case. The integral of 1 over x with respect to x. From differentiation, we had to bring the x to the top, right? That law remains solid. So this is the integral of x to the minus 1 with respect to x. The integral of this, just learn it off, is ln mod x plus c, where c is a constant. Right, you get marks for writing a constant of integration. So Kalafu, or Kulafu, I'll log if I butcher your name. Never forget it again in the future, please. I'll hit you 2 cough in your head. Don't forget your constant of integration, please. So this is a special case, very, very special. So for example, if I have 1 over anything, the integral of 1 over 16x plus 1 dx, one time you could say this is ln the modulus 16x plus 1 plus c. Now 1 over x squared, I could integrate it, okay? I could integrate 1 on x squared. This is not a special case. The special case is when I have 1 over x to the power of 1. This is the integral of x to the minus 2 dx, and just integrate it as normal. We add 1 to the power, minus 2 plus 1 is minus 1, and we divide by the new power, which is minus 1 plus c. X to the minus 1, we could bring it on the denominator, 1 over x to the 1, and we had a minus 1 in front of there. Alright? Plus c, of course. In a nutshell, that's basic integration. Basic integration. Time to apply it in some kinematics. Now, I'll go through kinematics in terms of using calculus in kinematics. Now, I want everybody to say this out loud. I do business if your brother day, if your mother day. I have business if you feel you're gonna look stupid. But say it out loud for me, guys. Zva. Zva. I'm waiting. Zva. S-V-A. Alright? S-V-A. Important. Zva. S-V-A. Zva. This tells us what we have to do where in order to get what. So you're talking about what we had to do where to get what? What else is that? S represents displacement. V represents velocity. And A represents acceleration. Going downwards is a differentiation procedure. And I'll explain what I mean just now. Going upwards is an integration procedure. What do I mean when I say that? If I have displacement, and I'll put this as a writing. If we have displacement or S, we need to differentiate to get V. And then we will need to differentiate again. We need to differentiate V to get A. Similarly, we need to integrate A to get V and integrate V to get S. I'll see if I could touch on area on the curve just now, right, boy? So let me go in some notes here, right? It will be here. Kinematics. Alright, so the beginning of kinematics is your distance time graphs and your velocity time graphs, and then we have equations of motion, and then is the SVA business. Okay, I don't have that here. Did I do that physically? Alright, so I'll use this one then. I should have it here. Kinematics. Yes, I do. Okay, good. So let's look at some questions here, right? Yeah, yes, I did differentiate. Good. Let's look at this question. Actually, I'll bring it across. We go bring across all these fellas here, right? Don't worry. Let me see what's going on in this question here. Now, it's very, very safe to make a couple of assumptions in kinematics, and the assumption is velocity is 0, displacement is 0. Okay? You'll see what I mean just now. S, V, and A will always be in terms of t, which is time. Always. So you're seeing in this question here, V is in terms of t. Now, when you have V in terms of t, and we differentiate that, we get dV dt. Now think about it, and I want you all to tell me. If I differentiate V, what do I get? If I integrate V, what do I get? So in the chat, put differentiate equals whatever, and put integrate equals whatever. Alright, no same. So a particle starts to move at O and travels in a straight line with velocity v centimeters per second, where v is equal to 2t minus t squared. The particle comes to rest at A. Calculate the value of t at A. I'm not focusing on that. I'm focusing on the acceleration. Now, acceleration, if I remember just now, zva going down is differentiating. So if I want acceleration, I have to differentiate velocity. So my acceleration will be the differential of velocity, which is dv dt, which is 2 minus 2t. Yeah? Now, the particle comes to rest at A. Oh god, we got how to do part 1. Calculate the value of t at A. So, if the particle comes to rest at A, then the velocity at A is equal to 0. Think about it. If you are at rest, then the velocity is equal to 0. So I let 2t minus t squared equal 0, and I have t into 2 minus t is equal to 0. I get t is equal to 0 and t is equal to 2. Add maths tomorrow. Now this makes a lot of sense because the particle starts to move at O, so t is equal to 0 will be one of the instances in time where the velocity was 0, which is at O, and t is equal to 2 will be the next instance in time when the velocity is 0, which is at A. So at A, t is equal to 2 seconds. The acceleration at A, again, acceleration is dv dt, which is equal to 2 minus 2t, and at t is equal to 2, the acceleration is equal to 2 minus 2 into 2, 2 minus 4, which is minus 2 meters per second squared. Now, if acceleration is negative, that means it's deceleration. The distance s from O to A. Now, I know that to get s, I need to integrate v. So the integral of v with respect to t, because it's in terms of t, that is s. So s is equal to the integral of 2t minus t squared with respect to t, 2t squared over 2 minus t cubed over 3, t squared plus c, where c is a constant, t squared minus t cubed over 3 plus c. Now, this is where your assumptions come into play. I have no conditions. Let me check and see first. Okay, good. Actually, we don't need to do that, but we will still talk about it. I have no conditions stating the distance at any particular time. I have none. Alright? If that occurs, I can make the assumption, since it starts to move at O, it's starting to move, I can state at O, s is equal to 0 and t is equal to 0. When s is 0 and t is 0, I can substitute that into my formula and get c. And I end up with c is 0. So therefore, s is equal to t squared minus t cubed on 3. Easy pickings. Now, given we have a short space of time, I don't really want to go too much into explaining because it will take a while. Because when I start to explain, I go explain from now until thy kingdom come. So this is what I would do. We reach here. Alright, we reach here. Third part says the distance s from O to A. We have to calculate that distance s from O to A. Now, all of these equations, acceleration, velocity, displacement, they are all equations that can be used to calculate that quantity from O. So for example, if I want the velocity, that velocity equation is the velocity from O. So I can use this equation to calculate the velocity of the particle at any point in time from O. Acceleration. From O, I can use this formula to calculate the acceleration from any point in time. And most importantly, displacement or distance, S. I want us to think about this a little bit here. Displacement is different from distance, okay? Displacement could be negative. And I think, I wonder why. Alright, let me explain the concept further here. If I get up from my seat and I walk up the road, and I walk up the road at the total distance of 20 meters, and then I walk back home and I sit back down in my chair, I will walk back 20 meters. I displaced 0 meters because from my starting spot, it come like I move at the end of my journey. My distance, however, would have been the 20 plus the 20, which will be 40 meters. Now, it's very, very important for you all to distinguish between displacement and distance. Extremely, extremely important. When we're talking about displacement and distance, displacement could be negative, distance is current. They ask for the total distance covered. Now the total distance covered, and this should clear up all your questions. The total distance covered, you have to take into consideration this thing called displacement, because S represents displacement. So displacement from O. So look at this table here. I calculated my displacement, which was t squared minus t cubed on 3. Okay? T squared minus t cubed on 3. Now, let's small this up a little bit here. I will just zoom in on the piece that we focusing on, which is this piece here. Some of you all might be tempted to do the last piece here and perform the integration, but I want to let you understand the table a little bit here, right? Remember, S is used to calculate the distance from O. So when t is equal to 0, I want to know what's going on. When t is equal to 0, S is equal to 0, which means I move. As yet. Alright. When t is equal to 1, from O, S is equal to 2/3. So, look at these, I'll draw over these things here, right? When t is equal to 0, brother man, I am move as yet. From O. This is O. When t is equal to 1, from O, I move 2/3. When t is equal to 2, from O, I moved 1/3. Yeah? So I still going in one direction. I am going in a different direction as yet, because my distance is increasing. All right, when t is equal to 3, my displacement was 0. Let me double check that. When t is equal to 3, my distance, sorry, when t is 3, I have 3 squared minus 3 cubed over 3. I get 0. Now what does this mean? It means I am moving forward, and then I move backward. I go on back to 0. So think about it a second here. I moved forward 1 1/3 meters, and then I move back to 0. From O, I move back to 0. Which means, think of it as walking. Alright, so we're over here, right? T is 0, T is 1, T is 2, T is 3. I return back to my original spot. So this is 1 1/3 I traveled here, and I must travel back 1 1/3 when my displacement is 0. Then, when t is 4, I go on negative 5 1/3, which means I'm going back in this direction here. Negative 5 1/3. So in total, this is my distance covered between 0 and 4. But between 0 and 4, my displacement is going to be negative 5 1/3 because of where I started. Now, if I had more time to explain it a lot better to you guys, it would have been nice. So all I have to do is add up these 3 quantities. 1 1/3 plus 1 1/3 is 2 2/3. 2 2/3 plus 5 1/3 is 8. So I traveled a distance of 8 centimeters. So it's in meters. 8 meters. This approach is the best approach I will suggest. Yes, you can use integration, but sometimes integration doesn't cater for that backward movement, right? Because the graph will fall underneath the x-axis. So let me go over it one more time now. Actually, I'm supposed to have more questions similar to this here. Let me see. I will have some kinematics here. These are past paper questions we're going to do now, right guys? Right, so all of these are past paper questions we're going to tackle here, right? Okay. So we're going to do 2011, 2012, 2013, 2014, 2015, 2016. Okay, we're gonna do up to 2016. I just run into the solutions. You all can pause and go through the solutions as I go through them with you guys here. All right, so let me just yeah, I want you all to see it properly, so just give me a second. Let me just change some stuff. All right, talk to me. What we looking like this so far, guys? Right, so let me just you can handle. Right, so I gotta change this here. Right. Okay, good. Alright, so that should be seen that there, right? So this is 2012 number 8. So let me read the question. Oh god, this was the bacchanal question, right? Now this was a kind of catch-ass question here. So please bear with me. Right, I'll take a while to explain it. Or go through the solutions at least. A car starting from rest. Information. A car starts at rest means that acceleration, velocity, time and displacement is equal to 0. Moves along a straight line, reaching a velocity of 24 meters per second. So we're increasing in velocity by a constant acceleration of 6 meters per second squared. The car maintains this constant velocity of 24 meters per second for 5 seconds and is then brought to rest again by a constant acceleration of negative 3 meters per second squared. Using the graph sheet provided, draw a velocity time graph to illustrate the motion of the car. So this velocity time graph here illustrates the motion of this car from A. I let the first piece be A to B. That will be the acceleration part, reaching a velocity of 24 meters per second. Then they say that how it maintains constant velocity for 24 meters for 5 seconds. So from T1, from B to C, that's a total of 5 seconds there. And then it decelerates to reach down to T2. Now, how to put this still, boy? It could be a little challenging understanding what's going on here because this question was a difficult question to do. You have your equations of motion where A is equal to U minus V on T. That is one of them. And you'll see it on the top right hand side, sorry. Another equation of motion that you all will have to know is these three equations of motion. So write them down, learn them, they are important. Use the equation that gives you one unknown. All the variables are defined on top. So back to the paper. Oh shucks, we're to 2011 yet, right? We go jump straight to 2012, right? In general, the area under a velocity time graph will give the distance traveled. See it again. The area under a velocity time graph will give the distance traveled. Now, the distance traveled underneath here, you'll separate it into a couple parts. Familiar shapes, I separated it into a triangle, a rectangle, and another triangle. And then I would have calculated the entire distance underneath the graph. Before I could calculate the distance underneath the graph, I need to figure out what T1 and T2 is. I use my equations of motion. I get T1 is 4 and T2 is 17. Now, another important point, the gradient of a velocity time graph, the gradient at any point on the graph will give me the acceleration. So for the first piece, they said that the acceleration was 6, so I calculated the gradient of AB and I got 6. Equated it equal to 6, and I got T1 is equal to 4. I did the same thing for part 2 in the orange, or I could have used an equation of motion to calculate the final time, T2. Now the next piece is kind of a bacchanalish piece, right? Important again, if two particles collide and they start from the same point, the only way they can collide is if their distances are the same. If they start from the same point and they collide, the only way they can collide is if their distances are the same. If their distances are the same, we can use that information to figure out any unknowns. For example, in this case here, a second car moving with a constant velocity drives past point A 3 seconds after the first car left point A. Calculate the length of time after the first car started that the second car meets it. Luckily, we have information in the form of a hint. Assume that the cars meet during the time when the first car is moving at a constant velocity. So this is where the piece of the graph comes from. And please don't be discouraged because this was a difficult question. The purple line illustrates the how to put it, boy, the velocity time graph for the second car. The second car will always be 3 seconds behind the first car. That is why at 9 seconds on the first car, which is the black graph, the purple car will be 6 seconds. So at any point t seconds on the black graph, the purple car will be 3 seconds behind, which is t minus 3. In the first 4 seconds over here, t1 is 4. So in the first 4 seconds, that is a1. In the first 4 seconds, car 1 traveled 48 meters. And in the first 4 seconds, car 2 traveled 1 by 32, which is 32. So in the first 4 seconds, car 1 covered 48 meters and car 2 covered 32 meters. So I just use this as a means of double checking. So in the first 4 seconds of their journeys, they might reach up as yet, because car 1 traveled 48 and car 2 traveled 32. So they might meet as yet. At time t seconds, car 1, look at it, car 1, which is the black car, will be 48 plus t minus 4 multiplied by 24, which will be the area of this part here, which will give me the distance traveled for this section here. The area underneath the purple graph will give me the distance traveled for the purple car, or the second car, which will be t minus 3 multiplied by 32. If both their distances are the same, I'll equate both of them. You could go through the working and you'll get t is equal to 6. Now, by all means, this was a difficult question. The velocity time graph part was a difficult question. I haven't seen one come this difficult after, so I don't think you should be that worried. So part B is the calculus. A particle moves in a straight line with acceleration that at any time when t is equal to 2, the particle has a velocity of 4 and is 8 meters from a fixed point. So conditions: when t is 2, v is 4, and when t is 2, s is 8. So I have two conditions there. Calculate the velocity when t is equal to 4. Well, I have acceleration, I want velocity, I have to integrate. So I have to integrate acceleration to get velocity. When I integrate acceleration, I'll integrate 5t minus 1, which is 5t squared on 2 minus t plus c. Condition: this is the calculate c. This is my condition, which is given in the question. When t is 2, v is 4. So I can substitute t and v to calculate c. So when t is 2, I substitute t is 2, v is 4. I rearrange and I calculate for c. So c would turn out to be minus 4 in this case, and v will be equal to 5t squared on 2, take away t, minus 4. The question says calculate the velocity when t is 4. When t is 4, substitute 4 into the velocity, and I get 32 meters per second. Next, they want us to calculate the displacement from O when t is equal to 3. Alright, so to get Vs, I need to integrate V. So I integrate V, I get 5t squared over, 5t cubed over 2 by 3 minus t squared on 2 minus 4t plus k. Now I'm not going to use the same constant c on this side here because I already used c before. So I use a different constant k. The condition states when s is 8, t is 2. T is s is 8 when t is 2. Yes, that's the condition. So I substitute that, calculate the value of k, and then the question asked for displacement. So I don't need to go through my whole, which part it is, the table business I was showing you all before. I don't need to go through that because the question asks for displacement, not distance. Although with me, I feel the chat kind of quiet. I'm feeling like all the men seeing some pressure right now. Now, I could understand why all is seeing the pressure, because if all you're not familiar with the concept of velocity, time, and acceleration, and kinematics on the whole, brother man, you're gonna be lost. So all I had to tell me, right? Let me know in the chat what's going on. If all you don't communicate with me, I can help all you. Alright, 2013 number 2014. Alright, 2013 number 8. A particle starts from rest and accelerates uniformly to 20 meters per second in 5 seconds. It continues at this velocity for 10 seconds. It then accelerates again uniformly to a velocity of 60 meters per second in 5 seconds. The particle then decelerates until it comes to rest 15 seconds later. Easy velocity time graph. Easy velocity time graph. Area under the graph is the distance traveled, and the average velocity is equal to the total distance traveled over the total time taken. Alright, so you have all the working here as easy as it comes. Calculate the area of each shape on the graph. Yeah, Mr. Graves, a little pressure. I could see why you were having a little pressure. Alright, the boys who I teach this to, regarding Ismail, Gerard, all these boys who probably here, are you all seeing pressure, understanding this? I just want to reiterate a little point that I made before. Ismail and company. Pressure? I'll continue here. Alright, so we have average velocity. Next is the kinematics part. A particle travels in a straight line in such a way that after t seconds, its velocity v from a fixed point O is given by the function v is equal to 3t squared minus 18t plus 15. So I have v. I know what I have to do to get velocity and acceleration. SVA, SVA. If I have V, yeah, some of the questions are difficult, Ashish. If I have V, I will need to integrate to get S. If I have V, I'll have to differentiate to get A. The values of t when the particle is instantaneously at rest. At instantaneous rest, the velocity is 0. Important point. And it's right there. At an instantaneous rest, velocity is 0. So I let the velocity be equal to 0 and I solve the quadratic. Get the values of t. Distance traveled. Distance. Remember, I'm looking for distance. Alright? Now, in this case here, watch what happened, right? I used the integration process and I got negative 16 meters. I could have easily used the table process to get the same result. Now the reason I used this process here is because we have a finite integral And the finite integral doesn't need the constant of integration. But let me bring it back a little bit and show you all the table. The table is important, real important. So I'm gonna just change this back again here. Right, good. So I'm gonna show already the table for this here, right? So we could do some work. After this question here, I'm going to jump into APs and GPs, right? If all you want a little more help on it, I mean, I will have to make a video, but the video will be kind of long. If all you for that, let me know. A finite integral is, yes, there are upper limits and lower limits. So this right now, what you're seeing on screen, this is a finite integral. Alright, now I'm going to attempt to calculate S, the equation for S. So I know S is the integral of V with respect to T, which is the integral of 3t squared minus 18t plus 15 with respect to T. So S is equal to 3t cubed over 3 minus 18t squared over 2 plus 15t plus C. Now the question itself gave me no conditions. It gave me no conditions. But the question did say, I'm going to open back to the question here. The question did say a particle moves in a straight line in such a way that after t seconds, its velocity v from a fixed point is given by that. So the question didn't give me no conditions, so I can assume that when s is 0, t is 0. I can assume that. So when s is 0, t is 0, c works out to be 0, so s works out to be t cubed minus 9t squared plus 15t. And I'm going to attempt to use the kind of table thing to figure out the displacement. Is displacement they want? The distance traveled. Alright, distance, you need to be a little more sensitive when it comes to distance. So we have we have t, we have s, and we have from O, what will be the distance? So the distance traveled by the particle between 1 second and 3 seconds. So I start with 1, I'll go with 2, and then I'll go with 3. So when t is equal to 1, I'll substitute 1 into my formula to get my displacement. Well, my distance, I get 1 minus 9 plus 15. I moved a distance of 7 meters from O. So from O, I moved a distance of 7 meters. Next, when t is 2, I'll have 2 to the 4 to the 8 minus 9 into 2 squared plus 15 into 2. I get 2. So I move backwards. So I move 7 here, and then from 7 I'll have 2 units here. I actually move 5 units in this direction here. So I'm going back 5 units. When t is equal to 3, I have 3 3s are 9, 3s are 27 minus 9 into 3 squared plus 15 into 3. I go on minus 9. So from 5, I go on minus 9, which means I pass in 0. So this is my pathway. 7. And then I come back 5 here. And I need to go, this is O. I need to go to minus 9 now. So I have to go to minus 9. So let me calculate my distance traveled now. From 7 to 5. And then I go in 2 here. And then from 2, I go into minus 9. So let's add up those distances. 7 plus 5 plus 2 plus 9 is why it have 16 here? Make a mistake. 3 3s are 9, 3s are 27 minus 9 into 3, right? Squared plus 15 into 3 minus 9. 7, and then I go on displace 2 units from O. Did I get 23 minus 7, sorry? Yes. Now the reason why I should have checked from O first. My mistake. My T is 0, S is 0. So from O, I move the distance of 0. Alright? So from 0 to 1, I move 7 units in one direction. Yeah? Yeah. From 0 to 1, I move the 7 units. So from 0 to 1, I move 7 units. From 1 to 2, I move the 5 units. From 2 to 3, I would have moved the, that is what? 11 units. Let me put it easier for you. I'm thinking about a way to put it easier for you here, right? Give me 1 second to think a little bit. Let me use my brain a little bit here. Okay. I remember when I was in this position, and it was a deep struggle. Deep struggle. 1 second. See, I really want all to learn this concept, right? Of using a table to calculate distances. So we have S is equal to T cube minus 9 T squared plus 15 T. And this S is from O. Now, I want to know the distance between 1 and 3. So we have time, we have displacement, and we have distance from O. 0, 1, 2, 3. Displacement is 0, so the distance is 0. When t is equal to 1, the displacement is 7, so the distance will also be 7. When t is equal to 2, the displacement is 2, so the distance now will be 7 plus 5. When t is 3, my displacement is minus 9, so it will be 7 plus 5, and from 2 to minus 9, let me check it here. That will be 11. So between 0 and 3 units, I would have traveled a total of 23 meters. Let me check something with the graph here. Give me a second, right? Earlier. Right, so I'm just going to check something with respect to the graph here, right? And I'll look at tuning to what I'm doing here. I'll look at what I'm doing, right? I am going to check how the particle looks, right? This will be the motion of the particle. T cubed minus 9t squared x cubed minus 9x squared plus 15x. This is the motion of the particle here. Okay? This is the path the particle takes in terms of distance. People want to know the distance between 1 and 3. So you see between 1 and 3, the particle would cover a positive distance, and under the graph will be negative distances. So, that's 4. At 3 is minus 9, and between 1 and 2, we would have traveled a distance of 7. We start at 7 here. Right, so we start at 7 here. We will travel 7 units, and then we will travel 9 units. So how to put this into perspective in the table for you guys? So we would have traveled positive, then we would, from here, would be V0. So I will check from here. I will start checking from here. So if I start checking at 1, I would have moved 0, 1 is 7. I'll start there, so that becomes my starting point. So from 1 second to 2 seconds, I traveled 5 units. So from 1 second to 2 seconds, I traveled 5 units. And then from 2 seconds to 3 seconds, I traveled 9 units. In the opposite direction. And that's the best way I could explain it to you guys here. Right, from 1 unit to 2 units, from 1 second to 2 seconds, I traveled 5 units here. From 2 seconds to 3 seconds, from O, I traveled minus 9. So from 5, I need to go 2 more, 1, 2, to reach 0, and then 9. So that'll be 5, 6, 7, plus 9, which is 16. Yeah, it's a little difficult to understand, but putting the concept over to all in a short space of time, that's the best I could do. I'm sorry, but that's the best I could do. Let me know if all you're comfortable with having probably a 2-hour long video on kinematics, because if that is the case, I will have to try my best to put it out there for you, right? I have to try my best. And the most I can do. I put out a kinematics video explaining everything, and you will have to watch the whole video to understand everything. You will have to watch it. No breaks in. You have to watch it. So let me know in the chat if guys what you want now. Alright. So I am waiting. I'm going on to APs and GPs. Now APs and GPs real easy. Real easy. Alright. 10 minutes. A AP is as a result of addition or subtraction. We have formulas and APs that we need to know. In an AP, T sub n will represent the nth term. A represents the first term, which is T1. D is the common difference. And D is calculated by subtracting T2 minus T1, T3 minus T2, T6 minus T5. So generally it will be Tn minus Tn minus 1. Generally. Right? So just minus the bigger term or the bigger term, not in terms of number, in terms of the term itself. So the fourth term minus the third term, the fifth term minus the fourth term, and so on. S sub n is the sum of the first n terms. So the sum of the first 5 terms, sum of the first 16 terms, and so on. And it's given by two formulas. One of the formula is n over 2 into 2a plus n minus 1 by d, or n over 2 into a plus l, where l is the last term. And this formula is very situational. You'll use it only if you have your last term. There's also a formula for t sub n, a plus n minus 1 by d. So it's very easy to identify an AP. To identify an AP, all I need to do is make sure that my common difference is the same in more than one case. So for example, if I have 2, 6, 8, 10, 12, and so on, I want to check if there's an AP. Well, A is equal to 2. D will be 6 minus 2, which is 4. D will also be 8 minus 6, which is 2. So therefore, based on this two not the same values, I can conclude that D is not the same, therefore is not an AP. Okay, next one. 2, 4. Alright, let me put 3, 6, 9, 12, and so on. A is 3. D is 6 minus 3, which is 3. 9 minus 6, which is 3. Once you get happening more than once, brother man, you're good to go. Therefore, this is an AP. Now, sometimes the questions will come worded, and the wording of the question is extremely important. Let me see if I get my question from my exam. Okay, good. Have that there. Find this. Find it now. Where did I save that? Where did I see? I think I deleted that, you know. Shit. Yeah, I think I deleted. I should have a copy of that paper in school. Damn it. Alright, that's more thing. Alright, that's more thing. Sometimes your AP's questions come in the form of words, and it's extremely important for you to identify your first term, identify a common difference. That's most important things, because all your formulas are based on your first term and your common difference, all of them. All right, once you know your formulas, be careful when you are applying your formulas. Just remember, S sum n is the sum of the first n terms in an AP. All right, now I will do this for you guys. I do have some AP's stuff here. Where's the worksheet for this? All right, so here what I want to do for me, right? This is what I want to do. Who will be willing to either make actually I could just, all right, this is what I'm going to do for you, right? I'm posting a link in the chat, which will direct you all to the Google Classroom. And when you all are directed to the Google Classroom, you will find the solutions or notes there. Okay? In the chat, I want you guys to tell me what topics you all want notes on. So do that right now in the chat for me. What topic do you all want notes on? So once you all tell me that, I'll take note of it, and I will put those topics in the Google Classroom for you guys. So alright, so I'm going to put that in the chat right now. Don't mind all the noise, I have plenty of animals. And once that comes into the chat, you all can go ahead and join the classroom. Give me what notes you all want. So here we have 12 nice AP's questions, really nice AP's questions, and we have the solutions for all of them. Alright, so let's go to number 1. Find the 31st term of an AP whose 11th term is 38 and 16th term is 73. So the 11th term is 38. Well, you have to know how to do your simultaneous equations. The 11th term is 38. So I work out my 11th term, put it equal to 38. My 16th term is 73. I'll work out my 16th term, put it equal to 73, and solve them simultaneously. Now, there's a trick with APs. In APs, you can take away terms in an AP. And in this worksheet, You should see that. Wait, I only do up to number 5. Right, number 6 is that. Number 7 is that. Ooh. Things echo come so hard. Right, things echo come so hard. Right, I will do number 6 as well, right? So actually, let me do number 6. Let me check and see if I have the solution for number 6. Alright, so I've seen some, I see Kevin put what he want notes on. So follow suit now, guys. What all I want notes on? Follow suit. Alright, this one is a nicer one. It have all the solutions here. Alright, so I'll put this one for you. Yeah, I have all that for you, Kevin. Josiah, for everything on Triggs on the channel, go and watch the videos. There's about 4 videos. If you watch that, no tricks question going to give you any problems. You're guaranteed to get full marks in the tricks questions if you watch those videos. Alright, you're getting that. I'm organizing this one time for all you guys. Now, I'm gonna put it here. So we have our AP's worksheet. We'll have our GP's worksheet as well. Yep. I'm trying to organize all these things for you, right, guys? These notes. Probability and statistics. Alright, so the statistics. There will be plenty notes for statistics, eh? Plenty. Plenty. Right, extremely plenty. Now the notes, could be a little difficult to understand because I have no explanations much in the notes. Right, you don't really have much in the notes. Right, you see that definition for standard deviation? I'm seeing it now. Learn your definition of standard deviation. It's in statistics notes number 2. paper 2 and paper 1, do four questions perfect and attempt the next 2 and full marks in a paper 1. That is for A done. I'll do arc length and area of a sector live. Right, we do differentiation and integration here. I'll put the kinematics notes. Right, I will put the kinematics notes. A man says circles. Let me see if I explain circles a little more here. Right, I have more work on circles here. Alright, so that's all I've seen there. Alright, let me do arc length and area of a sector. Real easy. To get a little context on radian measure, go and watch the Triggs videos, please. You need to learn how to convert degrees to radians. Simple formulas you need to learn. Arc length is r theta. So if I have a diagram, AB, this fella here is an arc, AB. This is theta, this is r. Theta must be in radians. If theta is in radians, your calculator must be in radians. Okay? Since your arc length is r theta, it's just a multiplication process here on your calculator. And that's it. Area of a sector is a half r squared theta. Both of these thetas must be in radians. Both of them must be in radians. And that is it. That is as simple as it gets. If they give you they actually give you the arc length and they ask you to calculate r, it's just a little rearranging of the formula. Okay? If arc length is usually symbolized as s, so s is equal to r theta, you can rearrange this to calculate r or to calculate theta, depending on what information the question gives you. That is it. That is it. This is as hard as they come for C-sec. Half r squared theta, bam shot, apply it. R theta, bam shot, apply it. Alright, Kevin? Yeah, Ismail, this is super easy. Super easy. Alright, so here what we're going to do, right, fellas and ladies? We're going to take our 5 now. And we should return about 8 o'clock tonight. Do our next 2 hours. We're going to do logs. I'm going to start with logs. A nice thing I'll show you all here. These are the list of topics. I'll do logs. And I'll do alpha and beta roots. How does that sound? Logs and alpha and beta roots tonight. If push come to shove, I will have to try my best and make a video for all you. Right, I go hard to try my best. Only if push come to shove. Tell me how that sound. Yeah, taking a 5, we're going on. We go till from 8 to 10 now. Right? From 8 to 10. Alright guys. Everybody should take a little break now. Take a breather. I'm gonna put the notes on the classroom. Go ahead and one time tell me if all you have access to the notes. I'm putting a link on the classroom itself for the notes, right? So new folder upload. Bam, bam, bam. I'm putting it now. Now go tell me if I get it. I'm putting it now. Right, or I will see me post a link. Right, I want her to tell me. I'm going to post something on the classroom now. Tell me if you all have access to it, clicking that link. I go in and try it myself. Tell me if you all have access to the notes using that link. You all should have access to the notes using that link. Full access to download and view. Okay? Tell me now. Logs not on the broad topic. Oh, look, somebody now sent me the broad topics here. Perfect. Alright, so we're taking a 5. I'm going on probably look at these broad topics. Thank you, whoever sent me the broad topics. Who is this that sent me the broad topics? Amjad. Alright, thanks for sending me the broad topics. So hey, I had to put the probability. I didn't put probability, sorry. Probability. So you guys can go ahead. I will see you guys promptly at 8 o'clock. I'm gonna put this in the probability there as well, right? So let's pick up on yourself and I'll see you guys 8 o'clock.